Right now, your brain is doing something extraordinary. Reading these words, understanding their meaning, and forming thoughts about them in real time. For decades, scientists asked one question: what if a machine could do the same thing? Not mimic it, actually do it. The answer to that question is sitting in your pocket, your laptop, and increasingly in nearly every system running the modern world. Artificial intelligence isn't magic. It isn't science fiction. It's math. Specifically, a very clever kind of math that teaches computers to recognize patterns the way experience teaches you. To understand how AI works, start with data, enormous amounts of it. When engineers build an AI model, they feed it millions, sometimes billions, of examples. Text, images, audio, numbers. The model doesn't memorize these examples. Instead, it learns from them. It adjusts itself over and over until it gets better at spotting what's relevant and ignoring what isn't. This process is called training, and it's essentially the AI equivalent of studying for an exam, except instead of nights, it takes weeks, and instead of one student, it's billions of calculations running in parallel. The core engine behind modern AI is something called a neural network. The name comes from the brain's own architecture. Neurons connected to other neurons, passing signals back and forth. Artificial neural networks work similarly. They consist of layers of nodes, each one performing a small mathematical operation on the data passing through it. The first layer might detect raw edges in an image. The next layer combines those edges into shapes. The layer after that recognizes shapes as objects. By the final layer, the network can tell you it's looking at a cat, a car, or a crowded street with startling accuracy. What makes this powerful is something called weights. Each connection in the network has a numerical value, its weight, which determines how much influence one node has on the next. During training, the model makes a prediction, compares it to the correct answer, measures how wrong it was, and then nudges every single weight in the network slightly in the direction that would have made the prediction more accurate. Do this millions of times across millions of examples, and the weights gradually settle into values that let the model make genuinely smart decisions. This process of measuring error and adjusting weights is called backpropagation, and it's the fundamental reason AI has gotten so good so fast. It's not that computers became smarter, it's that we found a reliable way to let them learn from their own mistakes automatically at massive scale. Language models like the ones powering modern chatbots take this further. They're trained on vast stretches of text, books, websites, articles, conversations, and they learn the statistical relationships between words. Not just which words appear together, but the deeper patterns of meaning, context, and reasoning that flow through language. When you ask one of these models a question, it doesn't retrieve a stored answer. It generates a response word by word, predicting at each step what the most coherent and relevant continuation would be. The result can feel like talking to someone who genuinely understands you, because in a meaningful sense, the model has internalized the structure of how humans think and communicate. None of this is without limits. AI systems are only as good as the data they were trained on. Feed a model biased data, and it produces biased outputs. Ask it about something outside its training, and it can hallucinate, now confidently producing information that sounds right but isn't. These aren't quirks to be patched later. They're fundamental challenges that researchers are actively working to solve. What's happening right now in AI isn't a single breakthrough. It's a compounding effect. Better hardware, smarter architectures, more data, and years of accumulated research have all arrived at roughly the same moment. The result is technology that can write, reason, create, and assist in ways that felt impossible just a decade ago. AI doesn't think the way you do. It doesn't have curiosity or ambition or awareness, but it has learned from an almost incomprehensible volume of human knowledge how to be genuinely useful, and that distinction between intelligence and learning capability is the most important thing to understand about the technology reshaping our world.